Hi everyone. Have you ever wondered how the Earth sculpted majestic land masses on its surface, or why the tectonic plates move beneath the Earth's crust? No, right? So don't worry, I'm here to explain how the tectonic plates shaped our Earth's surface. In 1977, two scientists published the most complete picture of the ocean floor that it had ever been created, which revolutionizes our understanding of the Earth, named Tarp-Heezen map by its collaborators. So this illustration was produced during sonar and measurements of the water depths. It revealed for the first time a complex network of the water mountains and ridges and provided key evidence that supported the emerging geological theory of plate tectonics. Now, this theory states that the Earth's outer shell, which is the lithosphere, is broken into two plates. Now, these plates shift and slide over the asthenosphere, which is the molten upper portion of the mantle. Let's understand about the layers of the Earth. The Earth, like an onion, consists of several concentric layers, each with its own unique set of properties and characteristics. The four primary layers are definitely the one that you see on the screen, the crust, the mantle, the outer core, and the inner core. However, geologists subdivided these layers into a complex structure that better describes the Earth's intricate composition and behavior. So, to make you understand, there are only three layers. Okay, you have the crust, followed by the mantle, and then you have the core. So, here in the picture, you have oceanic crust, followed by continental crust, and the lithosphere. So, now all these three things come under the category of crust. Then you have asthenosphere, upper mantle, and lower mantle. Now, all these three comes under mantle. And then you have outer core and the inner core. Now, outer core and the inner core will come under core. So that's why we say the layers of the earth is strictly divided into primary layers, which is the crust, the mantle, and the core. So the core is further categorized into outer core and inner core. The mantle is divided into asthenosphere, upper mantle, lower mantle, followed by the crust, which has the oceanic crust, continental crust, and the lithosphere. So the structure of Earth's interior is fundamentally divided into three layers, as we know. It is the outermost solid part of the Earth, which is normally about 8 to 40 kilometers thick. It's very brittle in nature. Nearly 1% of the Earth's volume and 0.5% of the Earth's mass are made of the crust. The asthenosphere, that is this part, this particular part here. So this part is located about 100 to 400 kilometers below the Earth's surface. So the name asthenosphere is actually, it's a Greek word which means without any strength, which is very weak, basically, describing its soft materials. So the asthenosphere helps the tectonic plates move like, a magical play-doh beneath them. Oceanic and continental plates meet and interact at boundaries that crisscross our planets because 71% of the Earth's crust is covered by water. We all know that, right? The majority of boundaries are found on the seafloor. So, when two oceanic plates tear apart from each other at a divergent plate boundary, the space between the divergent plates fills with magma and hardens when exposed to cold seawater. So, over millions of years, this process has built chains of water volcanoes and rift valleys called the mid ocean ridge. When the plates move apart, they rip open the Earth mid ocean ridge, which runs across the planet. There are few places on the Earth where the mid ocean ridge rises at the ocean, giving us the chance to see this phenomenon. Iceland is one of them. Iceland was once the underwater section of the mid ocean ridge. Over millions of years, it was pushed up above sea level by giant volcanic hotspot. Here we can see a divergent plate boundary, a stretch of the mid-Atlantic ridge with the North American and Eurasian plates spreading or rifting apart. Geologist and oceanographer Dr. Bob Whaler has come to this unique spot where crystal clear glacial water has filled this section of the mid-ocean ridge that has been raised above sea level.
Boy, that's truly amazing. I'm literally at the boundary of creation in Iceland. On my left is the North American plate right here. I can put my hand on North America. I can reach over here and put my hand on the Eurasian plate. And this is the very spot where the Earth is spreading open, about an inch a year, about your height in your lifetime.
When two plates are spreading apart in one section of the world, other plates are moving towards each other in a different area, forming convergent plate boundary. So in these kind of plate boundaries, one plate can slide underneath the other in a process called subduction. Or the two plates can crash into each other, creating a mountain range. The Himalayan mountains were formed when two continental plates collided. The Himalayas are a prime example of how tectonic plate motion can manipulate the Earth in extraordinary ways. So that's why I mentioned in the beginning itself that the tectonic plates play a crucial role in sculpting majestic land masses on the Earth's surface. So these colliding plates resulted in the formation of the highest mountain range on the planet, which is definitely the Himalayas. So the marks that you see here, okay, these puzzle pieces are nothing but all these puzzle pieces here are the tectonic plates. Now, 80 million years ago, India was approximately, say, 6,000 kilometers south of the Eurasian plate. Separating the two was the Tethys Sea. So this entire portion is the Indo-Australian plate. Okay, Tethys Sea. The Indo-Australian tectonic plate containing the continent of Australia, the Indian subcontinent, and surrounding ocean was pushed northward by the convection currents generated in the inner mantle. So for millions of years, India made its way across the sea towards the Eurasian plate. Okay, so I'll explain that in the next slide. The formation of the Himalayas. So like we know, when India and Tibet collided, instead of descending with the plate, the relatively light sedimentary and metamorphic rock that makes up the subcontinent of India pushed against Tibet, forces it upwards and created a massive mountain fold. So fold mountain. So what happens when these two tectonic plates come in contact with each other? They are forced upwards. Rather than descending, they are being pushed upwards, which creates a massive mountain fold, which is nothing but the Himalayas. Now, this process hasn't stopped. So the Indo-Australian plate is still moving towards Eurasia, still pushing Tibet towards, but this happens at the rate of 1 inch per year. The Himalayas continue to rise by an average of 2 centimeters each year. The highest mountains are only getting higher. On the Mediterranean island of Cyprus, we find an example of the convergent plate boundary that was raised above sea level many millions of years ago. The African and Eurasian plates collided. Dr. Bob has come to explore this place.
I'm standing on what was an ancient ocean floor, would have been thousands of feet beneath the sea. And what we're looking at is an area where the subsequent collision of these great plates, the African plate and the Eurasian plate, then began to force this part of the ocean floor up to where it is today. And you'll see these round-looking objects, and those are actually what we call the pillow lavas, because as the lava comes out, and no sooner does it come out, it's quenched. And then it expands and continues to quench and forms these pillow-shaped forms, and then it'll pop out, form another one, pop out, form another one. So you can literally see all these different areas in which the molten lava actually expanded out and then cooled.
The study of plate tectonics from the tallest mountains to the bottom of the ocean by the scientists help us understand the extraordinary processes that continually shape and reshape our planet, sculpting majestic landmasses, causing earthquakes and volcanoes, and supplying natural resources.